kind of a review. All right, so first I check that my dividend is in standard form, and then I put my divisor down the side, right? So you will have to do division on Friday's test. And I'm just saying this in all my classes, that if for some reason in this class, if we don't have school Friday, if there is a snow day, or if we're here and we're, I don't know what the snow's going to do in the rain and stuff. So saying it as a plan. If we're here and it's a delayed start, I'm giving the test Friday to whoever is here. If we don't have school Friday, I'm going to use the next 2 days, Tuesday, Wednesday, as final exam review days. And on your final exam, there'll be a subset that'll be kind of like maybe a 50-point instead of a 100-point polynomial test grade separate from your final exam. Because I don't want to start by taking a test on Tuesday or Wednesday. I want to do final exam review on Tuesday, Wednesday. So, but I do want to have an assessment on polynomials. So it would, no, we're going to take it as a test. I think people need another good test in this semester. And then you have all next week to make it up if you want to make up the polynomial test. Polynomials is short and sweet, and I think people need the opportunity to get a good test grade on just polynomials. The final exam is going to be more challenging. It's on more content. Yep. The final will be, I haven't done exactly how many questions. It's usually around 20 or 25 multiple choice that you can't use your notes on, and then like 10 free response that you could use your notes on. And usually you can just use your calculator on the whole thing. And it just counts as a test grade in quarter 2. But the only thing is you can't make it up because it's the end of the semester. So, okay, I put my x cubed term of my dividend in here. And then I put my x squared term at the top. This times this gives you this. Now you follow it down and you do that bottom box, 3x squared. So 3x squared is here. What? Yep, so then on my diagonal, these two circles have to add up to negative 2x squared. So I need negative 5x squared in this box. So then what times x will give me that? Negative 5x. Yep, so negative 5x goes on top. That puts negative 15x down at the bottom. And I'm trying to get to negative 14x's. So in these purple circles, I need a total of negative 14. I already have negative 15. I need to add back 1x. So it looks like plus 1 is the last term of my quotient. And I just need to figure out if there's a remainder or not. So I put 1 times 3 is 3. Let's see, I need to add up to negative 5. So it looks like I have a remainder of negative 8. So if I phrased this question differently and I said, is x plus 3 a factor? Would you say yes or no? It is not a factor because it had a remainder other than 0. So you try number 8 now. See if you can do 8, and we're going to go back to the rectangle problem in a second. Volume, yeah, so length times width times height. We're looking for that. You had a question this question. Did I do this right? Did you get a remainder of 4? Let me just check my work. Let's just do positive 42. So I just subtract 2, and then this is positive 14, right? So remainder of 4 looks right. All right. So if you could do 7 and 8, that's the level of difficulty of a division problem. So then I'd like you to try example 3 and 4 because it's going back to those shapes from geometry. So if you have the length of the rectangle and you know the area of the rectangle, how can you find the width of the rectangle? Divide, right? Because we know that area would equal length times width. We want the width. So can I divide by L to get L to the other side. So the width is going to be the area divided by the length. So you are going to take the length of the rectangle is going to go outside your box. This would be more of a challenge problem, but I think some of you are up for challenge problems here. So I'm going to put the width, the length is on the outside. The width is going to be my quotient up here. It should go in evenly, and the area is going to go inside. So 24x to the fourth is going to go inside as my first term. Huh? Yep, so go ahead. You guys do that division problem, and then see if you can look at example 4 on your own and get the answer. So let's see, I would need 6x squared. Ooh, that would give me what? 72x cubed. Oh, which is exactly what I need. So I would need 0 here, right? So 24x to the fourth plus 72x cubed, that gives me it exactly. So my final answer would be just 6x squared, I think, right? Because I would get 0 here, 0 here, 0 here, right? So there is no remainder. So my width would be just 6x squared. We haven't really had one that comes out like that, but would that make sense? 6x squared times 4x squared plus 12x. Does that give me area 24x to the fourth plus 72x cubed? It does, right? By the distributive property, I would get that correct answer. So my width would just be 6x squared. That was actually easier than I thought it was. And then try that other one. You guys talked about volume. A rectangular prism is just like a tissue box or a package, right? It has a length, width, and height. Volume is length times width times height from geometry. So they're giving you the length and the width. They're telling you the volume. You don't really have to do too much with division here. See what you have already. I currently have what? 4x squared times 6x cubed. So I currently have 24x to the fifth. So what is 48x to the eighth divided by 24x to the fifth? That's what I would have to multiply by to get my final volume. So it looks like, yeah, 2x cubed. So that would tell me that my height would have to be 2x cubed. So to me, it's an SAT type question. It's pulling in geometry and some polynomial work. Speaking of SAT, oh, here you go, back of 608, and then you can try a few on your own for 609. Tomorrow we'll do a different team test. You have a question? Let me do one example with them first. I'm going to have them do the bottom one in a second. Okay, so what's the total degree? I count up all the powers of x. This is an x squared term, and this is an x cubed term. So my total degree is 2 plus 3. So my total degree is 5. Not to be confused with standard form. In standard form, what is the degree of this polynomial? No. So you just did what we did over here. For this is a cubic function, guys. In standard form, we've never added things together, right? So in standard form, the degree is the highest exponent. This is called factored form. You have to add together the exponents. Don't confuse the two. That's the biggest mistake people make with degree. This we've named from the beginning as a cubic function. These guys don't get added together. But this needs to get multiplied together because it's in factored form. So big difference. Degree of 5. That tells me I have how many possible x-intercepts? 5. And if you forget, think about your friend, the quadratic. How many x-intercepts could a quadratic have? 2. How many x-intercepts could a linear function have? 1. So if x to the first could have 1, x squared could have 2, you follow the pattern, x to the fifth could have 5. Then you could think about turning points. How many turning points on a linear function? 0. How many turning points on a quadratic? 1. Follow the pattern. How many turning points on a fifth degree? 4. It's always one less than the degree. You don't have to memorize the rule. You just have to be able to sketch a couple graphs for yourself and figure out the pattern. Okay. So I'm looking at what will make this factor 0 and what will make this factor 0. This one's easy, -1. This one takes a bit of algebra if you're not sure what it is. So my zeros are x equals -1 and x equals, if you're not sure, you write out 2x minus 1 equals 0 and you solve for x by adding 1 to the other side and then dividing by 2, otherwise known as 1/2. So those are my two zeros. To sketch the curve, I don't know where the squiggles go. I need to think about the multiplicity. The multiplicity are these powers up here. -1 actually has an even multiplicity because it's a 2. So -1 has a multiplicity of 2, which is even, and 1/2 has a multiplicity of 3, which is odd. So multiplicity is when you look at these powers here. Degree is when you add those two powers together here. Degree versus multiplicity. So my degree is odd, but this multiplicity is even and this multiplicity is odd. So degree and multiplicities are different. All right, what will this graph look like? So my first step is I'm going to plot my x-intercepts. I have one that's -1 and one that's a +1/2. Now I have to think about my end behavior. What? What do I know about the right side of the graph? Look at the leading coefficient, positive. So that tells me the right side of the graph is going to be going up from that x-intercept. Now I think about, hey, before you switch, you were in radian mode the whole time, right? If you had to be. Okay, I just thought of that. Sorry. Okay. Physics is in degrees and calculus is in radians, and so many of my students will be like, I just did the whole test in degrees. No. Yeah, I know. I gotta keep reminding. Okay, odd degree. So down on the left, they have to go in opposite, odd, opposite. All right, so I just need to think about the squiggle in the middle. Which one had the even multiplicity? -1 is going to act like a parabola, x squared. So at -1, I'm going to have a little parabola bouncing off my x-axis. So my little parabola is going to bounce off, and then something happens down here. I don't know where my turning point is, but then I know I cut through kind of like a linear function. So there's sections of a graph. This section of the graph is behaving like a linear function. This section of the graph is behaving like a parabola. That's what this number is doing and this number is doing. It's shaping the graph. So I think that's kind of cool. It puts together everything from polynomials. In the next question, even puts in a piece of division. So in the next one, it says, all right, you need to graph this function knowing that x minus 2 is a factor. So we're going to start by trying to factor this out, and we're going to do division. I guess you could do it way down at the bottom of your page too. X cubed goes here. This is going to be a little bit challenging because there are 0 x's in the original function. So you might want to write that there are 0 x's. So when you're looking back at your dividend, you know there's 0 of them. So I shouldn't have done it here. This might be confusing with my boxes. You might want to do it down at the bottom. See if you can successfully divide and get a remainder of 0. Guess I should put up my division. This would be x squared minus 2x squared plus 8x squared plus 8x minus 16x plus 16x plus 16 minus 32. Should come out to a remainder of 0. This is a trinomial. This trinomial is factorable by the diamond method because I can think of factors of 16 that add up to 8. So I'm going to rewrite my polynomial kind of down here. This is really x minus 2 times x plus 4 squared. You could write x plus 4 times x plus 4, but since we're talking about multiplicity, it might be easier to write it using that multiplicity of 2. So this can be used for the other part over here. You might want to refer to standard form when you're thinking of your degree because it's a cubic function, right? This might be more confusing. You got to think about what's the degree of this. So see if you can answer those questions going across now, and then we'll just check our answers before I set you loose on 609. 609 has just minute practice to basically review. That'll be good for this the rest of this class. I'll give you a minute to try that last example on your own. See if you can go 5 for 5 on the answers. See if you can sketch a graph of it too. All right, are we ready to put it up? Let's see, our degree is 3, so that makes our zeros 3 and our turning points 2. We know that x equals positive 2 or x equals negative 4 are the zeros because those are the opposites. This has odd multiplicity because there's a 1 right there. This one has even multiplicity because there's a 2. So did you try to sketch the graph? Maybe take a minute, see if you can plot your x-intercepts, think about the end behavior, and think about the multiplicity before I put up the answer to that. let's see, I would have an x-intercept at +2, 1, 2, 3, 4, -4, up on the right because I have a positive coefficient, down on the left because I have an odd 3, and I'm cutting, let's see, where's my even multiplicity? I'm having a parabola at -4, so up, down, and then kind of back through, something like that. So you could even, before you sketch the curve, if you want to write like the word bounce and cut through or something so that you know, okay, I'm bouncing off here and I'm cutting through over here, just to help you sketch the graph. Well, it's starting with a positive leading coefficient, and it has to go down from here. So your squiggle could look different than mine. Like you could go straight down really far, but it does have to bounce off at that point. Okay, so you've got like a half an hour. You should be able to finish 609 today with a partner. Maybe work with whoever you want to work with the team test for tomorrow. So there's 610 as a challenge, but your only goal would be to finish 609. While you're working on that,